So guys, it's Mr. Selby here. Going to be teaching a quick lesson on algebraic proofs. Hopefully it will be kind of quick. We'll see what I can do on this. Hope everybody's having a good day out there. Let's go ahead. All right, so in the past we talked about points, lines, planes. We have not written any paragraph proofs yet. Today is the first time. So today we're going to do a little bit of proof writing using algebra first, and maybe get into a little bit of geometry proofs, okay? So as you guys know, geometry kind of builds on the stuff we learned in algebra. So today we are going to be using a good amount of algebra stuff here. So the point of this lesson is to kind of go through what proofs are and how to use them, okay? So today we're going to be learning about algebraic proofs, two-column proofs, formal proofs. All right. So here are the proofs. So we have addition property of equality. A equals B, then A plus C equals B plus C. The subtraction property of equality. A equals B, then A minus C equals B minus C. Multiplication property of equality. A equals B, then A times C equals B times C. Division property of equality. If A equals B and C does not equal 0, then A divided by C equals B divided by C. If A equals A for the reflexive. Symmetric property of equality. If A equals B, then B equals A. Transitive property of equality. If A equals B and B equals C, then A equals C. Substitution property of equality. If A equals B, then A may be replaced by B in any equation or expression. Distributive property. A times B plus C equals AB plus AC. All right. So you guys should already know a good amount of these. All right. The big three cheeses here are reflexive, symmetric, and transitive. Okay. Luckily, Mr. Selby came out with a few different examples, kind of help out on some of these, okay? So as you can see, addition property, if A equals B, then A plus C equals B plus C. So if A equals 5, 5 plus 3 equals the same thing as A plus 3, right? Because they both are going to equal 8. A is 5, and so 5 plus 3 equals 8, and A plus 3 equals 8, all right? Subtraction property, same thing. 5 minus 3, if A equals 5, 5 minus 3 equals the same thing as A minus 3. All right? Try and think of A as like 5 hats. Yeah, 5 hats that alpha has. Alpha has 5 hats. So if you subtract 3, it's the same thing as 5 minus 3. Okay? Then there's the multiplication property. So as you can see, kind of... As you can see on here, if A equals B, then A times C equals B times 3. So if A equals 5, 5 times 3 equals the same thing as A times 3, right? They're both going to equal 15. All right, next one is the division property. So if A equals B and C does not equal 0, then A divided by C equals B divided by C. So in this case, A equals 5, 5 divided by 3 equals A divided by 3. They're both going to equal like 1.67. All right, then we get to a little bit tougher ones up here. Give me 1 second, guys. Kind of shrink this down a little bit. There we go. Fantastic. All right, I think that's about as short as it goes. All right, so the next one we have is reflexive property. 3 equals 3, A equals A, 325 plus 7 equals 325 plus 7. Essentially, whatever you have here, on one side, as long as it's the same thing on the other side, they're equal. All right, it's like you got 3 pizza boxes on the left and 3 pizza boxes on the right. You have the same amount of pizza boxes on both sides. All right, symmetric property. Okay, so if you've got A equals 5 on one side and then you've got 5 equals A on the other side, they're the same thing. They're both equal. If greater than 90% is an A equals greater than 90%. You know, it's the same thing for equality, okay? It's kind of like saying a new T-shirt is worth $15 and $15 is worth a new T-shirt. You know what I mean? Like, that's what you could say for it. That's the symmetric property. All right, transitive property is a little confusing here. If A equals B and B equals C, then A equals C. Kind of confusing, but I kind of break it down this way. If Susan got the same, that should be an if. Let me switch that really quick. if Susan got the same grade as John, and John got the same grade as Becca, then Becca and Susan have the same grade. Like if Susan got an A, she got 100%, and John got the same grade, he got 100% as well. And Becca got the same grade as John, she got 100%, he got 100%. Then you know Becca and Susan both got 100% because they both got the same thing as John, right? So they both have the same grade. That's the transitive property of equality. And then you've got the substitution property of equality. If A equals B, then A may be replaced by B in any equation or expression. I don't think I made one for that one. I did not. Okay, so substitution, we've done this before. If I'll actually put it right down here. Substitution. All right, so if A equals 5, A equals 5, and you know 5 minus 2 equals 3, you can sub in A for any of those. So it would be A minus 2 equals 3. Boom, just like that. Any expression that you would like. Distributive property, you should have already learned this from algebra, but just go over it. A times B and A times C. Whenever you have a number here outside the parentheses and you have numbers inside the parentheses, you multiply the numbers, both numbers inside the parentheses, by the number on the outside. So A times B equals AB, A times C equals AC, and you add them together, AB plus AC. All right, that's the distributive property. Let's keep going. All right, so for proofs, all right, what we're going to do is you're going to have a really long equation like this, and it's going to be like solve. So obviously you're going to solve for A. So normally you would probably go through this equation and you would probably be like, oh, first thing I'm going to do is I'm going to distribute, then I'm going to combine my like terms, and I'm going to subtract whatever's left that doesn't have a coefficient from both sides, and then I'm going to divide by the coefficient on both sides, and boom, I've got my answer for the variable, which is all very fancy and everything, except it's hard sometimes to figure out why you decided to do something unless you wrote it out. So this is kind of like not just doing the equation, but also writing the equation, okay? So it kind of shows a little bit of reasoning too, because you have to explain essentially what you're doing, which makes it a little bit easier to grade if you're Mr. Selby. So you got your steps on the left, you got your properties on the right. Properties are the things we just went over, okay? All of these are properties. You can write any of these down, the one that fits, hopefully. All right, please don't write down a random one. All right, so first thing you always do is you always write down the original equation, and you can, in this case, they write original equation, but I always write given, and you can write either one. I think given is less letters, and I'm a big fan of only using 5 letters, and it looks like here they use a lot more than 5. It looks like 16 letters. That's a lot. Mr. Selby doesn't write 16 letters unless he needs to. So I typically just write given. All right. So then they distribute. Like I said, you would do 2 times 5 and 2 times minus 3a. You get 10 minus 6a, negative 4 times a, and negative 4 times 7. You get negative 4a and negative 28. Distributive. All right. They wrote a substitution property in here to combine your like terms. All right. So as you can see, negative 6a and negative 4a combined to equal negative 10a. 10 and negative 28 equals negative 18. Then addition property. You add 18 to both sides to get rid of that negative 18. 92 plus 18 should be 110. These 18s cancel out, and you're left with negative 10a. And that's substitution property. A negative 10a, divide both sides by negative 10. That's the division property because you're dividing by 10. You're doing division. A equals negative 11. All right, just to be clear here. You distribute, you add, you divide. Those are the properties you write down. You literally are writing down what you're doing. Again, makes Mr. Selby's job a little bit easier. I'm a big fan of that. All right, so A equals negative 11. Your turn. So do me a quick favor. I'm going to stop talking for about 5 to 10 seconds. I want you guys to try and solve this problem on your own. See how many steps you can write out. Typically, we wouldn't have you do this. I mean, I would like for you to try and write out the steps. You don't have to write out the steps. But if you could write out the steps, that'd be great. Great way to practice right now. Can't get it, you can't get it, don't worry. As you know, Mr. Selby's probably going to go over this. And when I say probably, he definitely is. All right. Hopefully you got D. Oh, yeah. A equals 7. I'm going to show you guys really quick how I did this. Hopefully you did it correctly. All right. Let me expand this thing just a tad bit. All right. Can I make this larger? Does that happen? A little bit. Okay. So I got my steps over here, my reasons over here. Hopefully, as long as you got 7, you should be good. Okay. So the first thing I did was I wrote given. All right, because that's what you're given. Distributed, substituted, like combined my like terms. Subtracted. For the subtraction property, I subtracted 6 from both sides, and then I divided by 8 on both sides, and I got A equals 7. All right. Remember, if you are confused on any of this, please reach out. Message me on Schoology. Email me. Come to office hours. Send me a postcard that says, I don't understand. Postcard probably wouldn't be the best way, but if you had to. In a pinch. Okay, if the distance d an object travels is given by d equals 20t plus 5, the time t that the object travels is given by t equals d minus 5, divided by 20. Write a 2-column proof to verify this conjecture. Wow. Very fancy stuff. Let's go over it. All right. Begin by stating what is given and what you are to prove. All right. Given d equals 20t plus 5. Prove t equals d minus 5 divided by 20. All right. First thing you always start with is the given. D equals 20t plus 5. All right, first thing you want to do is you want to get rid of that 5 on this side and bring it right up next to that D. So you subtract 5 from both sides, and that's the addition property of equality. All right, division property, you're going to divide by 20 on both sides, okay? That gets rid of this 20, and that gives this 20 over here, and voila. You just flip it using the symmetric property, because remember, A equals B and B equals A. Yeah, you can just flip-flop anything. As long as you can flip anything over an equal sign, all right? So T equals D minus 5 over 20. All right? All right, which of the following conjectures would complete the proof of this conjecture? If the formula for the area of a trapezoid is A equals 1/2 B1 plus B2, right, base 1 plus B2, base 2, height, times height, then the height h of the trapezoid is given by h equals 2a over b1 plus b2. So given a equals 1/2 b1 plus b2 times height, height equals 2a over b1 plus b2. Very exciting stuff. So you just need to figure out which proof you're missing, which statement. Why don't you guys take 5 to 10 seconds, or take a few minutes. I'm going to stop talking for 5 to 10 seconds. It'd be great if you guys could pause this and figure out the correct answer. All right, hopefully you're able to figure it out. Oops. All right, which one would it be for the multiplication? Just a quick look right here, multiplication property of equality. I kind of forgot to show you guys the screen before, so I'm going to give you like another few seconds. All right, hopefully you figured it out. It is indeed A. All right, for multiplication, as you can see, what you would have done here is multiply both sides by 2. All right, that would get rid of this 1/2 and add 2a over here, giving you 2a equals B1 in parentheses plus B2 times height, which is exactly this answer. All right. Booyah. So the fun begins. Write a geometric proof. If angle A is congruent to angle B, the measure of angle B equals 2 measures of angle C, and measure of angle C equals 45, then the measure of angle A equals 90. Write a 2-column proof to verify this conjecture. Let's begin. So you're given all the information, and you've got to prove the measure of angle A is 90. So this is actually pretty normal in geometry, where you're given multiple statements of information here. All of this, there's about 3 different pieces of information that you're given here, and you can use it all to help you be successful in this, okay? So first is what you're given, okay? Very second thing is definition of congruent angles, all right? Measure of angle A equals measure of angle B. We know that, right? It even tells us they're congruent, okay? So the measure of angle A equals 2 times the measure of angle C, right? Because we know A equals B, all right? And B equals 2M angle C, so like 2 times the measure of angle C, right? So the angle A must also equal 2 times the measure of angle C, right? Because it's transitive. This is Susan. She got the same grade as John, and John got the same grade, got twice as good a grade as Becky. So therefore, Susan also got twice as good a grade as Becky. Measure of angle A is also 2 times the measure of angle C. All right. Then substitution. We know angle C equals 45, so we just sub it in there. 2 times the measure of angle C, which is 45. Same thing as 2 times 45. Measure of angle A equals 2 times 45. Substitution, because we know 2 times 45 equals 90, we can just sub in 90 there. Measure of angle A equals 90. Booyah. All right, all right, all right. Okay. Let's try this again. If segment AB is congruent to segment CD, and segment CD is congruent to segment RS, and AB equals 12, then RS equals 12. Which reason completes the proof of this conjecture? Oh, let me give you your options. All right, I'm going to stop talking again so that way you guys can pause and try and figure it out on your own. Okay, ready? Now I'm going to show you guys the options. Which one is it? Okay, hopefully you select the correct answer, which in this case is transitive. Great job. All right, just to show you guys, AB is congruent to CD. CD is congruent to RS. So how is AB congruent to RS? Because transitive. All right. If segment 1 is congruent to segment 2, and segment 2 is congruent to segment 3, then you know 1 is going to equal 3. Boom. That's transitive. Just one more time. Susan is equal to John. John is equal to Becky. They all got the same grade then. So that means Susan must also have the same grade as Becky. Transitive. All right. So that is it for today. I hope you guys got a lot from this lesson. But if you didn't, or you're having trouble understanding it, please, please, please reach out. Don't just sit there behind the computer being confused. Seek help. Seek advice. Seek wisdom. All right. You got plenty of teachers that can help you out. You can come to any office hours. You can go to, you can message on Schoology. You can send an email. I mean, whatever you need, please, please, please reach out. Okay? We're here to help. All right. I hope everybody is staying safe, happy, healthy, and hydrated. All right. And please feel free to rewatch this video as many times as you like until you get it. All right. Awesome. Thank you. Bye.